In this video, we're going to talk about the complement of an event. And I'm going to show an example first, and I think that'll make it clear what a complement is. Suppose that the probability of it raining tomorrow is 35%. What's the probability of it not raining? Right? And you can kind of think about that for a second. If there's a 35% chance of rain, what's the chance that it wouldn't rain? Well, the answer is 65%. Right? How do I know that? Right? It's because, well, the chance of it raining and then not raining, those have to add up to be 100%. Right? So 35 plus 65, that adds up to be 100%. And what we've just done there is we've talked about the complement. Raining and not raining are called complements. Right? Raining and not raining, those are complements. And in terms of notation, this looks like this. So the probability of it raining, if I say that R represents the event rain, right, I could say this. The probability of it raining is 35%. And then the complement would be this. Right? So we could describe this as the probability of the complement of R, or we could just say the chances of the probability of it not raining. Right? So when you have this kind of line here, this means not raining. Okay? Or in this case, not event R. So here's our formal definition for a complement. The complement of an event consists of all outcomes in which the event does not happen. Right? Because we had that example. If it's raining, then the complement is not raining. Right? The complement is when the event doesn't happen. So here's two examples. When the event is flipping a coin and getting heads, the complement would be, well, let's think about that. If we're not getting heads, then we must be getting tails. Right? Not heads is the same thing as saying tails. Right? In this one, when the event is picking a Monday or a Wednesday, the complement would be picking days that are not Monday or Wednesday. Well, what days are not Monday or Wednesday? Right? Well, there's a whole bunch, right? There's Tuesday, there's Thursday, there's Friday, Saturday, or Sunday. Right? So not picking a Monday or Wednesday would mean we're picking a Tuesday, Thursday, Friday, Saturday, or Sunday. All right, so here's our formula, and it's pretty intuitive. Right? Again, this represents the probability of A not happening, or we could say the probability of the complement of A. It's just 1 minus the probability of A happening. Right? Or you could think about it as 100% minus the probability of A happening. Right? So let's look at a couple examples. Right? You're given a bag filled with marbles. You are asked to pick one marble without looking. If the probability of getting a blue marble is 0.25, what's the probability of not getting a blue marble? In other words, let's say that B is the event getting a blue marble. Well, we could say that the probability of event B is 0.25. So what are we looking for? We're looking for the probability of not getting a blue. In other words, we're looking for the complement of getting a blue, right? And we would represent it this way, the probability of not getting a blue. Right? And I think it's pretty obvious in this case. If there's a 0.25 chance of getting a blue, or you could think of that as 25% chance of getting a blue, obviously the chances of not getting a blue would be 75% or 0.75. Right? And if you use in the formula, that's just 100% minus 25%, or 1 minus 0.25, which is 0.75. Right? This works the same way as if we had used fractions. Okay? Let's say we've got that same bag of marbles, and let's say that Y represents picking a yellow marble out of the bag. So if I tell you that the probability of picking a yellow is 3 out of 5, well, what's the probability of the complement of Y? In other words, what's the probability of not getting a yellow? Right? And I think you could kind of see it. It would be 2/5. Right? And if you want to look at the formula, it'd be like this. The chances of not getting a yellow would be 100% minus our 3/5 chance. Or in other words, 5/5 minus 3/5, which is 2/5. All right. Last one, go ahead and pause, and I want you to read this and think about it on your own. So go ahead and pause and think about this and how this relates to complements. All right, let's check this out. All right, so we've got this school club that has 40 freshmen, 34 sophomores, 46 juniors, 80 seniors. Right? If you add that all up, that's 200 people. If you're to pick one club member at random, what's the probability that the student would not be a freshman? Right? And you can kind of see there's two ways to do this. Right? The one way to do it is, so if I say F is freshman, right? So we're really asking not freshman, right? What's the probability of not picking a freshman? Right? Well, you could kind of see that as, well, there's 34 sophomores, 46 juniors, 80 seniors, right? So you could kind of think that as, well, 34 plus 46 plus 80 out of 200, right? And what does that add up to be? That's 160. That's one way to do it. But I also want you to see this. Right? There's another way to think about this. Well, if we know that there are 40 freshmen, well, that tells me that the probability of picking a freshman would be 40 out of 200. And so if I wanted to figure out the probability of not picking a freshman, or the probability of getting a complement of picking a freshman, well, that's going to be 100% minus our 40 out of 200. Right? And so that's pretty easy. That's just 200 out of 200 minus the 40 out of 200. So the chances of not picking a freshman are 160 out of 200. Right? So two ways to think about it.